All right, this is now live. Well, hey everyone, my name is Fraser Kane, and I am pleased once again to moderate a discussion from NASA's New Horizons spacecraft. And so for the next hour or so, we're going to be talking with members of the science team from NASA New Horizons, with James Green from NASA's Planetary Science, and William McKinnon, who is remote over at the University of Washington. And so we'll take about, like I said, we'll take about an hour. We'll talk about sort of an update on what's happening with New Horizons. We will, you'll get a chance to hear from the team, and then we'll take some of your questions from the audience. So I'd like to introduce everybody who's with us today. So first, I'm going to start with the NASA New Horizons folks. Alan Stern is there in the room, and Alan, why don't you introduce yourself, and then everyone else who's in the room with you.
Hi, I'm Alan. I'm the mission PI. It officially stands for Principal Investigator, although sometimes I say it's the Principal Instigator for getting people to do things. And we have 4 members of the science team, 3 with me here in the room, and Bill McKinnon. And why don't we start with Kelsey?
Sure. Hi, I'm Kelsey. I'm a postdoctoral researcher on the mission, and my main area of expertise is geology and geophysics, but I also help with things related to the instruments on the spacecraft and the observations that we're going to take.
Perfect. John?
My name is John Spencer. I'm a member of the science team. I've been helping Alan with various versions of this mission for about 20 years. And I'm interested in the geology of Pluto, but also have an astronomical interest. We're looking at the moons of Pluto as we're approaching at the moment, getting an early look at the data from an astronomical point of view while it's still an astronomer's planet and we haven't got the detailed pictures of the surface yet. So I'm interested in many aspects of the mission.
Dr. Robbins.
My name is Stuart Robbins, and right now I'm working on helping translate what the scientists want to do with the spacecraft into what's actually going to get done. So we have to convert the "we want" into computer commands and then send those commands back to the scientists in some language that is human readable. And I've been working on that. And then after we actually go through Encounter and Closest Approach, I'll be helping Kelsey with some of the geology that we're going to be doing, so some of the science, actually.
That's fantastic. Bill McKinnon, you're out there.
Yes, I am. Hello, everyone. I'm Bill. I'm a professor at Washington University, which is actually in St. Louis, not in Seattle. And I'm in what we call a theme team devoted to geology, geophysics, and imaging. And I serve as one of the deputy leads for that. In fact, John Spencer is the other deputy lead. And I'm basically very interested in anything to do with Pluto, but especially its origin and evolution. And I'm wanting to seize control from the astronomers and make Pluto a geological world.
Fantastic. And then Jim Green is the Director of Planetary Exploration at NASA headquarters. Jim?
Thank you, Alan. Indeed, it's a great opportunity to talk about Pluto and what we're about ready to do. I am the Director of Planetary Science at NASA headquarters. On the Pluto team, I actually am a newcomer. I came on board just a few months after it was launched, about 9 years ago. So that's been following it ever since.
That's great. So, as I mentioned beforehand, so, we'll take some time and we're going to talk to everybody on the mission here. But you can interact with us live as well. And so the way you can do that is, if you're watching this video anywhere, you can. It says that New Horizons is interacting with the audience, and if you click that app, and then you can post your questions there. We'll see them come up, and as we go through this broadcast, I will bring those questions to the relevant people. So, but I've got a few questions of my own, and I think because this is the second of these Hangouts that we've done, it really is this ongoing narrative, a hero's journey, if it were. So, Alan, when last we saw our heroes, I guess New Horizons was just about to wake up, as I recall, and we were sort of concerned about what was going to happen, and now it has woken up and is rapidly approaching Pluto. So can you give us sort of an update on what's happening with the mission?
Yeah, thanks, Fraser. You're right. Last time we spoke, the spacecraft was finishing its last bit of hibernation on the long 9-year cruise to Pluto. We woke it up in December and then began the distant parts of the encounter in January. And since January, the first 3 months are called Approach Phase 1. They're primarily dedicated to 2 kinds of activities. One are helping us home in by taking optical navigation images with the cameras on board and sending those images back to the Earth for analysis. As a result of some of those images, we made a very small course correction in March. It was right on target. We're about to start a new campaign of optical navigation imaging this weekend, in fact. The other thing that we've been doing on approach the last 3 months is what I call environmental monitoring. Our 2 plasma sensors and the dust instrument have all been essentially continuously taking data about what the Kuiper Belt heliospheric environment is like. They're giving us a baseline for interpreting the measurements at Pluto. But things are about to swing into a higher gear. Today is the last day of Approach Phase 1. What we call AP2, or Approach Phase 2, actually begins this weekend and will last until about 3 weeks before encounter. So we're looking forward now to training the cameras and spectrometers on Pluto and its system of satellites, continuing the environmental monitoring. We'll be moving into high gear with navigation and the kinds of debris searches that John is in charge of with his team. And lots of that data will be coming back to the ground. Currently, the best images just show Pluto as barely resolved, only a dot in the distance. But by the time that AP2 is over in June, you'll be seeing images of Pluto like nothing ever from any Earth-based system. So we're really looking forward now to transitioning, as John said, from an astronomer's kind of target to a planetary science target, and that's going to be happening in the near future.
That's fantastic. So, you know, you've provided some of the highlights, some of the big phases you're going to be doing up until now, and you sort of talked about some of these different kinds of aspects. You're interested in the sort of environment around Pluto, and I'd like to talk a bit about that. What kinds of, you know, you're talking about moons, potential particles, atmosphere, you know, what kinds of things are you going to be expecting to see as New Horizons gets closer?
Okay, John's going to take that one.
Okay, well, we're interested in the environment of Pluto for a couple of reasons. One, just because it's a scientifically fascinating environment where we have not explored this kind of world before. Pluto has 5 moons that we know about, maybe more that we don't know about. We don't know how those moons got there. We don't know how Pluto is interacting with the solar wind that our instruments will be measuring as we go past. There's a great deal to learn about Pluto's surroundings from that point of view. But we have another more immediate and practical reason we want to know about the environment around Pluto, which is that we are going to be flying through that environment at high speed, and we need to be sure that the spacecraft is going to be safe as it makes its close approach to Pluto and does all its measurements, and so that it can live to tell the tale and send us back all the fabulous data that it's going to be taking. So one of the things that I've been thinking a lot about the last couple of years is, as we're approaching Pluto, how we're going to ensure a safe passage for the spacecraft through the system. We are going to be starting in just a few weeks, taking long exposure images of the whole region around Pluto so that we can see if there are any new moons that might be producing any debris that could be dangerous to the spacecraft, or if we actually see rings of debris themselves orbiting Pluto in regions that might be dangerous to us. If we see anything like that, we'll be pouncing on it, we'll be analyzing what orbits those moons could be having, or what kind of rings we might get from those moons, and make sure that the spacecraft is going to be safe as it goes through the system. And we have various alternative strategies should we find something that looks dangerous, that we can turn the spacecraft so its main antenna is facing forward. I think I will. Okay, you see now we've got the spacecraft facing the camera here, and you can see most of the spacecraft is hidden behind this great big main antenna that we use for pointing at the Earth, but we can use this as a shield to protect us should we think we're in a dangerous situation. Or we can do different trajectories as well. But all the analysis we've done so far suggests that we will not need to use any of these strategies, because it's very hard for anything in the system to be in a region that can hurt us and cause a threat to the spacecraft. But we'll be doing those analyses. If we do come up with anything, if we do find anything, we'll be ready to deal with it.
So you've talked about how you're going to need to be ready to deal with this, and of course, New Horizons is what, 4 light hours away? It's very far away from us here on Earth, and so it's like playing a video game where you have to wait 4 hours, 8 hours for every move that you make. So, Stuart, I know you're handling a lot of this aspect of getting the spacecraft to deal with the situation. So, how do you like this video game?
I've started to get good at adding 4 hours and 24 minutes to everything, or subtracting it, because it's in all of our lists of everything that we're doing. There is an Earth receipt time and a spacecraft time, and sometimes you care about when stuff is on the ground, and sometimes you care about when the spacecraft is doing something. So with John's hazard observations that we're doing, and moon searches and ring searches and all this stuff, it's like we care about, okay, this is when the spacecraft took this stuff, so we know when that was done. Here's how long it takes to get to the ground. Here's how fast they can do their analysis, and here's the decision process to figure out what we're going to do next. And figuring out that system and figuring out, well, we do have this delay going on is an interesting logistics issue. For stuff closer to home, it's a lot nicer. Like the moon is what, only 2 light seconds away or something? Yeah. Mars, roughly 20 minutes away. So it's easy. And we talk about with rovers on Mars, like, okay, you have to have some sort of autonomous system, but with New Horizons, there's a lot more that you have to take into account because of that delay.
Yeah. And then Kelsey, what are you hoping? What's your sort of like your greatest hope that we may discover at Pluto when New Horizons gets there?
Right. Well, that's always a fun question. I'm hoping that, and I'm pretty sure we will, see some kind of, at least an expression of a geologic form that we haven't seen before. We'll definitely see some familiar things like craters and some kind of fault scarps probably, but undoubtedly we will see something that's different, and that'll be the fun part, figuring out how those features were formed.
Yeah, so it's almost like even with the Dawn mission, right? There's going to be something there that nobody was expecting. Whether it's going to be like Iapetus's Ridge or cryovolcanism on Enceladus, there's going to be something that we're not expecting. So, William, when the spacecraft when it moves from the astronomy phase to the geology phase, when does your work really kick in, and what kinds of things are you going to be looking for?
Well, just like Kelsey says, I mean, we're looking for novelty, but we're also looking for the familiar and for the combinations. And Pluto has all sorts of things happening on it. It's not just a world that is being bombarded. It's not just a world that might be active internally. It has an atmosphere. It has ices that are very volatile and move around, and we can see the patterns change over the decades, even from the Earth. And we'll finally get up close and personal and be able to see what's going on. It'll be probably Mars-like in its level of activity, even today, no matter what. So I think just the complexity of the planet will be revealed for the first time. Then we can maybe begin to tease out what the history has been. That's the job of geology. Right? And then also maybe what lies beneath the immediate surface that we can see. And being able to use all the instruments at once, to be able to take the compositional data from our infrared spectrometer and apply it to the units that we see with the regular cameras, that'll be an entirely novel experience for this class of worlds.
James Green from NASA, how do you sort of fit New Horizons in with the other fleet of spacecraft that you're managing over? I mean, as you said, you've only been working on this for 9 years, waiting and hoping, but it's been flying for longer than that. I mean, give us some perspective on how this is sort of impacting NASA.
Well, this is a remarkable achievement for mankind. I mean, the ability for us to be able to get in the outer reaches of the solar system and look at a whole new population of objects. We're just becoming aware of these objects over the last 15 or so years, those objects in the Kuiper Belt. Pluto right now is the one we believe is the largest. There may be others that are larger, but further out. And it's just that whole era of brand new discovery. Now, relative to the other missions, New Horizons is a beautifully compact, well-organized set of instruments. Some of the high-tech instruments we've ever launched certainly out in this far in the solar system. But you know, every spacecraft we do in the solar system, it has a lot of unique aspects about it. And that's what makes this business really exciting. Well, once again, New Horizons is going to visit a place that we've never visited like this before. And that's really exciting.
Yeah. So I've got a couple of questions that have already come in from the audience. So, Alan, I'll fire these over to you, and then you can sort of hand them off as you wish. First question, and this is sort of people have been waiting for, when will we see something better than Hubble? When will we finally get those images that are better than, and really, for me as a space journalist, I've been using the same images of Pluto for a decade now. So when will I get to use some better ones?
Yeah, that's a really good question, and a lot of people ask that. I'll speak to it for a minute, and I'll ask John to say a little bit more. Both of us are experienced Hubble users. In fact, many of the images that people use of Pluto made by Hubble are actually from a program that I PI'd in the 1990s with a particular instrument that was on the Space Telescope at that time. And those images, which are the best ever done by any telescope built by humans, can only barely resolve Pluto because it's so far away. Just put a few pixels across it, and yet they're fascinating because we can see bright and dark regions that vary as the planet rotates. And it's really enticing. You want to see more, but until New Horizons gets very close, we haven't been able to. So we've been using those same images for a long time, and I know that's frustrating. But that will start to change in May. In May, we'll start to have images that are just as good as what we can do from Earth orbit with the Hubble. And then as we go closer, they'll become noticeably better throughout the month of June and into July. In fact, by the time that we take our very best images, they will have a resolution less than 100 meters, about 5,000 times better than anything that's ever been done. John can tell you a little bit more about that, and so I'll hand it over.
Yes, we've had a sort of a friendly debate on the team about when we'll be able to say the images are better than anything we've had before, because it's going to be a gradual transition, because the images that we have right now from Hubble or from telescopes on the ground are quite fuzzy, and as we approach, we're taking fuzzy images right now, and they just gradually get less fuzzy. So the boundary between as good as and better is itself fuzzy, but part of it's going to depend on how much processing we do to the images. There will be images that come in middle of May, maybe late May, and they're going to look like fuzzy blobs. But by the time you've done a lot of processing of the kind that we've done to the Hubble images, you'll be able to start to pull out details of those that may well see things that we've never seen before. And it's going to be an interesting game. How quickly can we process those images from the middle of May to pull out all those details before we get even better images in the beginning of June, which will clearly show those things that we've worked so hard to pull out of the data from 2 weeks earlier. And from then on, it's just going to snowball. New things are going to be showing up every day pretty much at that point. And we're going to be glued to our screens through June and early July, and every day there'll be new discoveries. It's going to be amazing.
Great. So this question comes from Stephen Hawkins. Has a decision been made as to where New Horizons will head after Pluto?
John, you want to take that, or Jim, you want to take that?
Sure. Well, what of course will happen in New Horizons is it will continue to make progress to leave the solar system. It's on a path to do that. Scientifically, the team will be really busy in many different ways, such as analyzing data, such as also beginning to pull together their thoughts on potentially the next object in the Kuiper Belt that New Horizons could go to. Now, for us at NASA to be able to approve that, we'll have to receive their thoughts through what we call a proposal, and then that will be evaluated. And then an aspect of that is, the funding and how long it takes to get to that next object out there. The really good news is that Hubble Space Telescope, once again, has come in and not only provide us the best images of Pluto that we have right now, but also look for Kuiper Belt objects that New Horizons could get to, and there are a couple candidates. So I know a lot of analysis is still going on by the team to be able to look at that, and they're going to be so busy, I don't know how they're going to sleep.
John, why don't you say something about the two candidates?
Yeah, I can say a bit about that. So though we will not have approval or funding for a mission beyond the Pluto system until we've written proposals and been through that review process. We've been laying a lot of groundwork so that we're ready if we do get the funding for that. And yeah, we've spent a lot of time, as Jim mentioned, looking for objects beyond Pluto out in the rest of the Kuiper Belt, which extends out for another 1 billion kilometers or so beyond Pluto. There's hundreds of thousands of worlds out there. There's so many that we were pretty sure that somewhere along the trajectory that we're passing beyond Pluto, there would be something close enough for us to pay a close-up visit to. But it sure took a lot of work to find that. We did a lot of searches from telescopes on the ground, some of the biggest telescopes with the biggest cameras in the world. We found a whole bunch of stuff out there, but nothing that was quite close enough for us to reach with our spacecraft. So in last year, we turned to the Hubble Space Telescope, the most powerful tool that we have, and we got a lot of time on the Hubble to look in more detail for fainter objects that we would have missed seeing from the ground. And we found several, and this time, because of the power of Hubble, we were able to find 2 that we actually can reach with the spacecraft. We have to choose between those and then propose to NASA for the funding to carry out a mission to one of those objects. And we'll be looking at other objects on the way if this is approved that we won't pass so close to. So that groundwork has been laid, and we'll be ready when we get the approval, or if we get the approval, to go ahead with that.
And just to say a thing or two about the targets, one is an arrival at the very last days of 2018 in late December. The other would just be a few months later in early 2019. And these are much smaller targets than Pluto. Pluto's 2,400 kilometers across, and these are more like 50-ish kilometers across. They're the things we call planetesimals that built the dwarf planets. And they're kind of midway mass-wise, or at least logarithmically, between comets like Rosetta is orbiting now and small planets like Pluto and the others in the Kuiper Belt. And by flying by one of the 2 of these, we hope, again, if this mission is approved for an extension, to be able to connect those dots of accretion so that we have a spacecraft that's orbiting a comet out of which the planetesimals were made, study one of those on a flyby out in the Kuiper Belt where it's cold and never been significantly evolved, and then fly by Pluto, not in that order, but have all that data to connect the dots of accretion and understand how the worlds of the Kuiper Belt were built from the bottom up.
So, a lot of people, when they hear about the mission, they get really excited about the potential for finally seeing Pluto up close. One of the sadnesses, I guess, is that it's going to be such a rapid flyby. And so I'd be interested to sort of help people understand the physics of the mission in terms of the velocity that you're going, the kinds of some of the flybys that you've had to do to pick up velocity, and the kind of the balances that you had to make to be able to even do a flyby like this, and maybe what it could have taken to perhaps go into orbit. Because
I'll say a little about that, and then I'd like to see if Bill McKinnon would add some things to it. He's been on other flyby missions, for example, Voyager, at the beginning of his career, and can add that perspective. So let me start by saying, in order to meet the requirements of the original NASA competition for a Pluto mission, we had to go very fast. NASA wanted a mission that would arrive in the 20-teens after having launched in 2006. And to build up that kind of speed is a tough task in itself. We put a small spacecraft on a really big rocket. We topped it with an extra 3rd stage. We did a Jupiter flyby to add even more speed, and as a result, we crossed the entirety of our solar system to the very frontier in record time. In fact, we crossed the orbits of each of the planets, setting a new record. Mars, Jupiter, Saturn. No spacecraft had been faster to any of them. But now we've got all that speed behind us, and we're going to fly through the Pluto system with that very high speed. But we knew before we launched, in fact, when we designed the mission, that we would be doing a fast flyby. So we designed the instruments to compensate for that. They're very, very capable in terms of sensitivity, in terms of their ability to take data rapidly. And as we said, we start doing the best stuff ever done sometime in late May, and we have all the way through late July where we're going to own that system. And everything we do in that period of 8 or 10 weeks is going to be brand new. And even at the day of closest approach, we conduct several hundred observations, storing all the data like nuts. A squirrel would store his nuts for the winter. We put that into big solid-state recorders, flash memory, to be downloaded to the from the spacecraft to the ground over a period of more than a year. So although we have to take the data very fast, that's how New Horizons was designed, to do exactly that job. But Fraser, from your standpoint, you'll be seeing new things, and so will we, all across the rest of 2015 and almost all of 2016, because it takes a long time to get all the data back to the ground from 3 billion miles away. And let me turn it over to Bill to talk about his experience with flybys of the giant planets with Voyager.
Well, if you cast your mind back, you know, the Voyager missions were sent to Jupiter and Saturn with the possibility that one of them, Voyager 2, would go on to Uranus and Neptune if its extended mission was approved, just like our mission. So, but each one of those encounters was a complete revelation. People were basically going to explore the giant planets. They really, I think the scientific community, the planetary science community, didn't really understand just how amazing the individual worlds that orbit the giant planets would turn out to be. Although people caught up with this idea. So by the time we got to Neptune and Triton, its big moon, it was quite an event. And I anticipate that Pluto will be the next great thing in this sequence of first explorations. And I'll just amplify some of Alan's remarks. You know, with the Voyagers, this is mid-1970s technology. We had TV cameras, and there was a tape recorder, but most data came back live. That's how it was done. By going to Pluto and going fast, we give up the live broadcast, but we have these big solid-state memories, and two of them, 264 gigabits each. So we're going to just fill this puppy up with all this fabulous data as we go by. And then we'll take our time sending it back without any loss. So we're all looking forward to this real treasure trove of completely novel information from the edge of space.
I'd like to add a couple things.
Oh, sure.
You know, in planetary science, the approach that we have used tremendously successfully over our nearly 50 years is one for which we fly by, we orbit, we land, we rove, and then we return samples. And so as you can see, where we are with Pluto, this is our first attempt at a flyby. What we'll find, I know, will be so exciting that the scientists then will have to get together and make some decisions on whether we should go back and orbit it or whether there'll be higher priorities elsewhere, and then propose those things to NASA, for which then we'll consider those. But indeed, this really tells you that this is the last great flyby of an unknown region in the solar system. It's really, so to speak, the end of the exploratory phase, the initial exploratory phase of understanding our place in this solar system, and it opens a new chapter of really now beginning a deeper understanding of how all these objects fit, how they evolved, how they might even have affected life here on Earth. You know, everything is interconnected. And so this is a big step forward for us to learn about these objects.
Yeah, I mean, I think that's a really great way, a great perspective to put that into place. Just that we've only been exploring the solar system for the last couple of decades, and be patient. You know, it's exciting that we're going to be seeing Pluto for the first time, but don't worry, this won't be the last time we'll see it. So Jeff Maggio asks, do we expect to see subsurface oceans on Pluto like we see on other icy bodies? And this is a pretty exciting time with the subsurface, or I guess all of the cryovolcanism we're seeing on Enceladus, potential plumes on Europa, interesting features on Ceres. It seems like these these icy features and subsurface oceans are across the solar system. So where do you think Pluto will stand in this?
Fraser, that's a great question because we have two of the world's experts on this hangout. In fact, Kelsey Singer is going to say a little bit about it, and then I want to go back to Bill McKinnon as a geophysicist and talk about the possibilities of internal oceans on both Pluto and Sharon.
Sure, yeah. So I'm sure Bill will talk a little bit more about this aspect, but scientists have modeled that there could be still a subsurface ocean on Pluto. But one way we might be able to tell is by looking at the surface features that we see. So on some of these other worlds that you've been talking about, there are clear indications that there's more going on below the surface, and we can tell that by looking at all the really cool features we see, like the tiger stripes at Enceladus' south pole. There's plumes. On Europa, the craters look funny compared to Ganymede, which is its neighboring moon. So there could be lots of signs that will give us clues to the subsurface.
Bill?
Yeah, I'll pick that up. So some signs are really obvious, like when you go by Enceladus, you see water vapor and chemicals and particles erupting out of the surface. Now that may or may not mean an ocean, but basically we've done enough work that we've convinced ourselves there really is one. And you can go to a place like Europa where we don't know if there are erupting plumes yet, although there have been reports, and we can look at the surface and we see that parts of the ice shell are basically broken up into what look like basically icebergs that have floated around in a kind of mush and then refrozen. So we'll obviously be looking for these sorts of direct signs, certainly on Pluto, but there are also more subtle ways that we might be able to tell things that are going on, sort of like the pattern of faults on the surface, the overall shape of the satellites, what's actually on the surface. You know, whether it's, let's say in Sharon's case, which we really haven't talked about Pluto's big moon, but, you know, it has a different kind of surface than Pluto. It's really mostly water ice, like the icy satellites of the giant planets. But we know spectrally from the Earth, we can actually see that there's ammonia ice there, and that lowers the melting point of water, and that really allows an interior of a body with just a little bit of extra heat to remain liquid. So there are all sorts of more subtle inferences, and I suspect that once we see these data, once John and all the rest of the team members begin to talk about it, that we will have a very lively debate as to whether, in fact, we can actually say that there is an ocean on either body. But just like Kelsey says, the overall pattern that we're seeing across the solar system gives us the possibility that icy worlds, because they're warmer on the inside than they are on the outside, can harbor oceans. And basically, water is denser than ice. That's why it's not on the surface. It's on the inside.
So sort of a similar question, this one comes from Laurel Kornfeld, which is that a study about a year ago argued that Pluto's atmosphere might never completely freeze out during its 240-year orbit. Will data from New Horizons provide us enough information to tell us whether or not this is true? And I'd like to put this in the context of sort of a larger question, which is just that we are seeing Pluto at a very special time during its orbit, this time when it's sort of at its closest point of its orbit and starting to move out, and we're going to be seeing some changes in the environment around Pluto. And as you do this flyby, will you be able to get any insights about some of these features that may change over time over Pluto's orbit?
Yeah, I'll take that. We are lucky to be going by Pluto at a time when it is near its closest point to the Sun, and we know there is a pretty active atmosphere at the moment, an atmosphere that we'll be able to study in many ways with the spacecraft. But Pluto's atmosphere depends on the frost on its surface. At any given time, most of the material that would be in the atmosphere is actually frozen out, and it's just a small amount, mostly nitrogen, but some other gases as well, that are in the atmosphere. And there's a continual interchange between the frost on the surface and the atmosphere, and that's what keeps the atmosphere as dense as it is. So with New Horizons, we're going to be able to map exactly where those frosts are. Right now, we just have some sort of educated guesses about that. And by knowing where those frosts are, we'll be able to say, well, this region will be coming more into sunlight as Pluto's angle to the sun changes, or this area will be going into darkness. And from this, we'll be able to say a lot more about how that frost is going to be heated and supply the atmosphere in the decades to come. And this is going to be just one of the many ways we'll be able to do some kind of weather forecast for the future of Pluto.
Yeah, that question that you asked, Fraser, the paper that came out last year was actually led by members of our team, including Kathy Olkin and Leslie Young, predicting that the atmosphere won't collapse. There's a wide range of debate about that for just the reasons that John described. We understand the physics very well. We know how to code the physics into the numerical models. But once you code the physics in, you have to put in a lot of details about the starting conditions. And it's the starting conditions that we don't know enough about because, as John says, we don't have good enough images to know where the frost is. And which frosts, that is the methane versus the nitrogen versus the carbon monoxide, for example, are where. But New Horizons will resolve all that to a much better extent than we've been able to from the Earth. Then we can run all those models again and make better predictions than we can today. In addition, some of the images that we take may be able to shed light on whether the atmosphere collapses or not directly. If we look, for example, for terrains that look like the Mars polar layered terrain, and find things like that that could be evidence of seasonal snows over each 250-year orbit with deposition and then sublimation and deposition and sublimation. That could be a very strong hint from the data itself. So we're definitely interested in that problem. It's a great one, and we don't have to wait until 125 years from now when Pluto's at aphelion to test it. Hopefully New Horizons will let us do that.
Right. Well, as James said, we'll do a bunch. We'll do all 5 stages, so we'll have time over the next 248 years to keep track of the whole process. So this question comes from Aryan. What types of instruments will be used, and what data is expected to be collected? So this would be, I think, a great opportunity to talk about some of the instruments that are going to be on New Horizons, and sort of what kinds of information they're going to be gathering from the encounter.
So there's a bunch of us here, and why don't we we'll just go around the circle, and each person can talk about a different instrument. And Kelsey, you can start with anyone you like, and we'll just move around. And then I think we'll give one to Bill and so forth.
One of the easy ones.
I can talk about MVIC.
Why don't you do that?
Sure. Okay. So we have an instrument that's going to take color images, which means that it's taking pictures in different wavelengths. And we have a couple of those, but one of them is called MVIC. I actually don't know what it stands for.
Yeah, it's the multicolor visible and infrared camera.
There we go. Multicolor visible and infrared camera. So as the name suggests, it's a camera. So it's going to be taking pictures, and we can put those different colors together to give us an idea of what we would see if we were actually there ourselves. So that's going to get some high-resolution pictures as well. So it'll help us with the geology and looking at the composition associated with different geologic features.
I'll talk about the ALICE ultraviolet spectrometer, which is going to be used to study Pluto's atmosphere. It's a small instrument about the size of a shoebox. It only requires about 2 watts, if you can believe that, to run the spectrometer. Its command and data handling system, everything. And it's very advanced. Let's compare it to the Voyager ultraviolet spectrometer, which had 2 pixels. Thanks to the march of technology, the ALICE instrument has 32,000 pixels. And that illustrates the kind of power that we're bringing to this reconnaissance. This instrument will be used to study the composition of Pluto's upper atmosphere, potentially study its atmosphere all the way down to the surface, telling us about temperature and pressure profiles and composition. It's going to look at the surfaces of the different satellites as well. And it may do a couple of other things that could tell us about some surprises, but I'll hold back on those and let John take the next instrument.
Well, I'll talk about LISA, which is actually very intimately integrated with MVIC, the color camera. It uses the same telescope, a lot of the same optics, but it is looking at infrared light reflected from the surface, which is going, and this is, if you're technically inclined, is wavelengths about 1 micron to 2.5 microns, just a few times longer than the human eye can see. And this is a part of the spectrum that has an incredible amount of information about surface composition, all the different frosts that we've been talking about, the nitrogen, the methane, the carbon monoxide, other things like carbon dioxide and water, all will absorb very specific wavelengths within the range that LISA can see. So we'll be taking pictures with LISA, and they'll be, they won't be as spectacular just to look at the pictures as some of the other instruments. They'll be will have a couple of hundred, maybe 300 or 400 pixels across Pluto. But every one of those pixels, we are looking at 200 different wavelengths. And we can slice those wavelengths in many different ways to pull out the composition of every one of those pixels. So it's not just, oh, this is this bright, but this piece of Pluto is 30% nitrogen, 23% methane, whatever it is. And it's going to be an incredibly powerful instrument for understanding what Pluto is made of, literally.
And particularly when we couple that to IMVIC and other imagery of the geology, so we can see what the different geological expressions are in terms of their composition.
Okay, I'll cap off the imaging ones with Lori, and to sort of make this more complete. I mean, I would guess a lot of people are familiar with some of the stuff on Mars. You have LISA, sort of like Prism, giving you this very detailed, very small area of high-resolution spectral stuff, and then you have something like HiRISE, which is black and white with a little bit of color, and that's sort of the analogous one for MVIC. And then you have something like CTX, which gives you a broader view, black and white, and that's sort of LORI. So LORI is the big imager that's on New Horizons, and it is a black and white camera, but it's mostly visible light, and that's what we're using a lot now to do this optical navigation, so make sure that we're pointed exactly where we want to be and headed exactly where we want to go, and that's the one that's going to give us the best images ever come mid to late May, and that's the one that's really going to give us the roughly 100 meter per pixel stuff when we do our closest approach. So that's the one that, from a geology standpoint, I really like, because I want that high resolution images stuff that I can really get in there and see what's going on. And so that's sort of my favorite one, is the LORI, and that's also going to be the one that's going to be used for the search for moons and rings and other things as well.
Great. Okay, so Bill, you want to pick up radio science or the two plasma instruments?
Let me do radio science, because in reality, the radio science experiment, or REX, which is the antenna and the transmitter and receiver, is the most important instrument on the spacecraft. Why? Why is it more important than the picture-taking devices? Well, because if we can't get the data to the ground, we don't have anything. Well, all kidding aside, the radio science experiment allows us to precisely track in Doppler the spacecraft as it goes through the system when we're not actually taking data. So we'll get really exquisite measurements of the masses of Pluto and Sharon, and we'll be able to check that against basically what are calculational inferences from Kepler's third law from the system. So it's really going to improve that sort of thing. Plus, there's more. We can actually point the spacecraft, point the antenna at Pluto, and take its temperature. We pointed at the planet not to listen to aliens, but to actually get radio waves that are sensitive to the temperature of the subsurface. So we can make sweeps across Pluto's surface and actually determine the temperature of the surface directly, and that goes into the modeling that John and Alan were just describing about the atmosphere and its possible collapse, and will actually help us interpret the occultation data that we're going to take with the ultraviolet instrument as well, because we'll be sweeping right over the part of the surface where we're going to get the occultation track.
So I'll talk about the two plasma instruments, and then Stuart's going to round it out with the dust counter. We have, as I said, two plasma instruments. This is actually an area of expertise where on this Google Hangout, Jim Green is probably the very best expert, because that's his science area, magnetospheric physics. But I know he doesn't know the instruments because he's got to manage dozens of missions. We have two instruments that are called SWAP and PEPSI, and PEPSI's job is to sample material coming off Pluto's atmosphere directly and tell us what atoms, what composition it's made of. And then SWAP's job is actually, I think, one of the most interesting experiments we're carrying. SWAP measures the solar wind at very high time cadence. And you might ask, what does that got to do with Pluto? Pluto has an expanding, escaping atmosphere that escapes into the solar wind, and there's a boundary where the two meet and there's a pressure balance. And SWAP's job is to measure the solar wind on approach every few seconds until the solar wind cuts off when we're in the upper reaches of Pluto's atmosphere. And when we know that cutoff distance, we can put it into the computer models and determine the escape rate from Pluto's atmosphere directly. So it's a very clever experiment. It's measuring the solar wind so that when it stops, we learn what Pluto's atmospheric escape rate is. And I think it's one of the reasons we probably won over competition was because SWAP is such a clever instrument, but that's just my opinion. Now, we also have a student-built instrument. It's a dust counter, and Stuart's going to tell you more about that.
Yeah, so the final instrument is called SDC, that's the Student Dust Counter, and when I get talks about this, people wonder, like, why do we care about the dust? And it's kind of like, because we don't know about the environment out there in the solar system. I mean, we really don't, and just the fact of dust particles hitting this detector is going to tell us what the size distribution is of these particles, what the broader environment is, and when you fit that in with SWAP and Pepsi, and Pepsi spelled with 2 P's and 2 S's, but when you fit that in with those instruments, you learn a lot more about the space environment out there in the outer solar system. And if we ever want to send human space flights out there, we really have to know all about the environment, not just the big stuff, like, say, a few meter or a few kilometer sized moon orbiting Pluto, but we need to know about all of the tiny stuff that might puncture our spacecraft that could be bad if you want people out there and breathing. So, I mean, the SDC it's sort of remarkable in its simplicity and what it's doing, but it's an amazingly powerful instrument to tell us about what's going on out there.
Yeah, if I could add just one thing to that, dust may seem small to us, but out there in space, when we look at other solar systems, dust, because there's so much of it, is one of the things we see most easily. So this allows us to connect observations of our solar system with observations of other solar systems and make cross comparisons and inferences about what kind of worlds are making the dust and whether there are planets in these other solar systems.
So I've got a question that comes from Daniel Bamberger, and I'd like to give Daniel a shout out as well because he's been doing a great job of answering other people's questions in the in the chat. But Daniel asks, there will be parts of Pluto's surface in shadow at all times. So will there be observations with other instruments, not LORRI, of the surface features there? And I think just to sort of expand on this question, because it is such a quick flyby, you're not going to be able to see the entire surface of Pluto the entire time. And so, you know, give people sort of a context of which parts we are going to see and sort of what some of the downsides are going to be.
John and I are going to do that one. That favorite instrument of Stuart's called LORRI, which is basically our long focal length imager, is the one that's going to first get better images in May than we've ever had before. But as we approach closer and closer, it's going to let us map the far sides of Pluto and its satellites a few days before closest approach when we last see those, and we'll get pretty good imagery. We don't know a thing about what they look like now, those far sides, but the images that we will have, thanks to LORRI, even from a few days out, will be about like taking an inexpensive pair of binoculars and looking at the Earth's moon from your backyard. So pretty good. We'll get the general lay of the land for the far sides. Then the other problem that we have is because Pluto is tilted like the planet Uranus. It's on its side. It's currently experiencing a polar night, just like in Antarctica in the winter, over a big fraction of one hemisphere. But even there, we've thought of a way using LORRI to image in the polar night. It's pretty clever, and John's going to tell you about it.
Yes, what we're going to take advantage of the fact that Pluto has this big moon in its sky, Sharon, that is shining even at night on the regions that haven't seen sun for a decade or two at this point. And it's pretty faint moonlight. It's going to be quite challenging to take pictures in those very faint illumination conditions, but we're going to give it the college try. As after we go past Pluto, we're going to turn back and look back at the night side of Pluto, those permanently shadowed regions, illuminated by the light from Sharon. And we're just going to take dozens of long exposure pictures, and we're going to then have a very interesting time processing those to pull out those very, very faint details that should be illuminated. We're interested because we want to know, is the atmosphere condensing out on that what is now the winter pole? You'd kind of expect that it would be, but expectation is one thing and reality might be something quite different. So is there going to be a bright polar cap? So even though these images are going to be hard to analyze, they'll be very faint, we probably will be able to see if there is a bright polar cap there being illuminated by the moonlight.
Now, Sharon itself is a is a pretty interesting object, and if Pluto wasn't even there, I'm sure there'd be mountains of science to be done just from Sharon alone. So, we've talked a lot about what kinds of information we're going to learn from Pluto. I would love to know, put into context, what are we going to learn from Sharon as New Horizons goes past?
Well, I'd like Bill to chip in on this as well, but all the same investigations that we're doing of Pluto, we're doing of Sharon. So we'll be mapping Sharon at the same resolution. We'll be getting the same resolution for the color imagery. We'll be taking LISA, the instrument John talked about, and making composition maps with thousands of pixels on Sharon's surface. In fact, over 10,000 locations with a composition. We'll be using radio science, as Bill said, to measure its mass. We'll use the ALICE ultraviolet spectrometer to search for an atmosphere around Sharon, which is a possibility. So there's a very strong correspondence between the science at Pluto and the science at the big moon Sharon. There are two primary targets. And I think Bill can add a little bit to this, and so we'll hand it off to him.
Yeah, I think one of the most interesting aspects is that it's a binary world. And Sharon is half again as big, 50% as large as Pluto. So we're looking at what we think is the outcome, actually, of a catastrophic collision and merger of two Pluto-scale worlds long ago. So we hope to see clues on both worlds that may tell us about how this really happened. Plus, both worlds will evolve differently. They may have slightly different compositions. We're going to find out. We suspect, but don't know, just like John says, we suspect things, but we have to confirm or be surprised by what we actually learn, that Sharon will be a less evolved world, and therefore we'll be able to see farther back in time in the Pluto system, and by that I mean both its internal geology and also the resulting cratering record, the bombardment of small KBOs, Kuiper Belt objects. So we hope to see literally the evolution of the Kuiper Belt written on the surfaces of Pluto and Sharon in comparison.
Fantastic. So just don't forget about Sharon. That's all I'm saying.
Oh, I have.
Okay. So we've got about 5 minutes left, and so I just want to sort of start to wrap things up. And I think, for everyone who's been watching right now, I'm sure their minds are swimming with questions and things they're going to want to learn. I'm sure we'll be doing this again as we get closer, but I would love to sort of, Alan, if you can give people some resources, some places they can go, because you folks are publishing a mountain of material already out there on the internet, and people can do that. And people can join in the discovery as the data starts to come back with us. So how can people get involved?
Well, there are a lot of ways to get involved. That's a great question, and thanks for putting that at the end so people could see how to take what they've learned today and deepen it. One way is social media. The project has Facebook and Twitter accounts, and you can just go to either of those applications. You can go to Instagram, you can go to Tumblr, you can go to other social media engines and go out and just search for Pluto New Horizons or NASA, and you'll get lots of information that way. Another way is coming on the 14th of April. That's 3 months to the day before our close approach flyby, and NASA will be hosting a pair of news events in the afternoon from NASA headquarters where Jim is, where scientists on the panel, Jim himself, myself, will be there and giving briefings on the details of the flyby, how the data comes back to the ground. Bill McKinnon, who's on this Hangout, will be speaking about the payload and the science as well. So that's a really information-rich afternoon on the 14th of April. We'll be releasing a press kit that is a pretty thick volume about the spacecraft design, about the encounter design, the scientific objectives, things like that. Then beginning in June, there will be regular NASA television updates about New Horizons. They'll get more frequent as we get closer. We're planning an entire day and a half of activities right around the closest approach, and at the same time there'll be news releases about discoveries as they're being made, about accomplishments. We'll be telling you about the results of John's hazard searches, for example, or about course corrections, and of course we'll tell you when we've made the flyby that it's been accomplished. And so there's going to be a lot more that's coming out. I would say that the little bit of trickle that's been coming out in the first few months of 2015 is about to turn into a fire hydrant and then a waterfall of different kinds of information. And I think your best bet is to Google New Horizons and find all the sources that you like and follow those. And if anybody wants to chip in other things, please do.
I'll just add that tomorrow will be just 100 days out from the closing count.
Oh, that's great. Yeah, so if you're watching this right now and you haven't already, make sure you follow New Horizons on Twitter. Follow them on Instagram and Facebook and Google+, so all of your social media, because that's, in many cases, in my experience anyway, one of the first places that you'll start to see that information come out. Definitely check out the NASA New Horizons website. There's a lot of great raw images there. We often troll through there to find some latest data and images, as well as I know you have a page for that through JHUAPL, so through the SWRI site. So there's a bunch of good websites you can go and check out, and I highly recommend you follow them all. So I think we're sort of reaching the end of this Hangout. So I'd like to thank everybody involved for participating. Thank you, thanks James for showing up from NASA headquarters. It's great to add that NASA perspective, and thanks to William McKinnon from Washington University, and thanks to everyone there at the NASA New Horizons team you're in Boulder, right?
We're in Boulder, and thank you, Fraser. We really appreciate it.
Glad to help. I really appreciate the hanging out with you guys. I learned a bunch. So who knows when we'll do this again. So Kelsey, you've got to turn off the the live broadcast. Thanks, everybody.
Bye.